Hey, Evan Reese here. We're still talking about input fields in Onshape, and I know that sounds like a kind of boring subject, but it goes real deep. So in the previous three videos, we've built up to some pretty interesting and complex workflows where you can build more logic into your models. But in this video, we're going to start to pull back that curtain even further and realize how thin the veil is between your Part Studio and actual FeatureScript code. In fact, these windows, the input fields are just windows into FeatureScript itself. And you can put anything in there. So in this video, we're going to get weird with it and do some code in those fields. All right, let's first talk about maps. So let me show you what that looks like. Inside of the variable tool, I'm going to go back to any, and I'm going to say size is the name of this variable. And to create a map, it looks like this. It has an open bracket and a closed bracket. And then inside of that, it has key value pairings. So it looks like that. The key is going to be probably a string of some kind, doesn't strictly have to be, but I'm going to use strings. A string is denoted with the quotation marks. And then the value is going to be probably not a string. It's going to be, I mean, it could be, but I'm going to use like 1 inch, for example. So if I wanted to create multiples of these, I can separate them with a comma and add as many as I want. And this can go on, I mean, this can contain a huge list. So what I'm going to use it for in this example is just width is going to be equal to 10 millimeters. Length is going to be equal to 5 millimeters, and height is going to be equal to 15 millimeters. And now if I come in here with that cube custom feature that I use just to slap geometry out really quick, I can say that the X size is going to be equal to size. That's our variable. I'm going to hit enter to get the variable, and then dot, and I can type width. And there we go. So that's now equal to that size dot length and size dot. See how this is going to fail, and that's because I didn't actually put the hash symbol. So there you go. So that's actually calling the variable. Now this whole thing is driven by a single variable, and I'll admit that I actually wouldn't do it this way, but it is a good way to demo how maps work. I haven't yet found as many uses for maps as I have found for the next thing, which is arrays. But I do want to make you aware that they're here, and I'm sure that there are some extremely important use cases for them. When you need it, you need it. So one example might be that you could use certain inputs as a key to another value. So if you had, for example, a size of a sprocket, you could use that size as the key, like a diameter, and it would tell you, it would spit out like, you know, the number of teeth or something like that. So you can use not just these values here, like your key. Let me just try an example. It could be 1 inch is the key actually, and it's going to give me 5 inches back. So if I have, let me get rid of this. Test. So it should be, if I go size, and in this case, I can't use dot notation because I'm not accessing a string. I'm going to put it inside of brackets, and I'm going to say 1 inch. And because I put that in there, it's going to return 5 inches. So if you have a list of values that are related to each other in some way, you can create a big old list as a map in a variable. And then as your model values change, you can use those to find the corresponding value in your list. So pretty neat stuff. All right, but let's move on to a container that I think is actually more useful even than the map. So this container is called an array. I'm going to call this list. And to create an array, we use brackets like that. And inside, you can put any number of things that are comma separated. So now I have a list that would cause problems, but you know, it doesn't have to be numbers. It could be strings or anything. So there we go. That's my list. And the way that we get at these things is with an index. So these all have a corresponding index beginning at 0. So 0, 1, 2, 3, 4, and so on. So if I wanted to get a value, I'm going to set this back to any, and I can go list. And inside of brackets, I'm going to put my index. So that gives me the first value because the first index is 0. I can put in a 6 and it'll give me a 1. I don't remember how many there are in there. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Was that right? So maybe 9 would give me test. Yeah, there we go. So this one returned a string called test. So these can be anything. In fact, they could be another array. You can have a list of lists, and that can, that's the exact same way of structuring data as a spreadsheet. So you can have rows and columns. That's how tables are defined. All right, so let's take a look at what we can actually do with something like this. One example is to actually create a list of arbitrary values to use in a pattern. So imagine that I am wanting to pattern something and the spacings are not even, and I want to use a linear pattern so that I'm not having to manually do this. I can use an array to create a list of the links that I want. Let's call it 5 inches, 8 inches, 9 inches, and 15 inches. So these were somehow the important values that I have. I also want items to get added to the pattern when I just type a new one in this list. So instead of having a fixed count for the pattern, I'm actually going to use a function that counts how many things are in my list. So I'm going to use, set this to a number, count, and I'm going to use a function called size. It doesn't autocomplete, but this is where you're starting to understand that all of this is available in FeatureScript. All of FeatureScript is available. In fact, let me just look at this FeatureScript documentation. So we have all of this stuff in here. And some of these are the things that you recognize as functions that autocomplete. Our absolute function is here. But a lot of these don't autocomplete. I think like this exp2 does not autocomplete. But if you were working with binary math for some reason, this is a really helpful function to know that you have. So all of these things are available, and you can get there by coming up here, going to the help menu and going FeatureScript documentation. It'll open up a new window, and then you go standard library documentation, and you can start scrolling through here and seeing what's available. You might want to go to the side and just grab like, the math util or something like that. All this stuff is available. So you can do pretty much anything that you see in here. One place where you will not be able to do is any function that requires an input of context or ID, especially context. I'll show you more on that later. But anyway, all right. The whole point here is that some of the functions that are available are not going to autocomplete for you. So size is one of those, but we're going to put list inside of size, and it's going to return, oh, I did it in the wrong field. I'm going to put it in number, paste that in, get rid of inch. Cool. So now it's telling me how many items I have in my list. If I add an item, let's say I go ahead and add 18 inches. Now we have 5 items. Cool. So all I have to do to add to my pattern is add an item to this list. So now let's make our pattern. The top plane, I'm going to sketch a circle using C. There's my origin. Don't care how big it is. I'll make it 1 inch. I'm going to extrude this at a depth of something very thin, 1 millimeter. And then for the starting offset, I'm going to change it to a variable called offset. And that variable I'm going to make equal to list. And then I'm going to give it an index, 0. So that's going to return the first value in our list, 5 inches. Now, what we actually need to do is be able to iterate through the list. And in order to do that, we're going to use a variable to iterate through that. So I'm going to create a new variable called I. Hopefully this will make sense in a second if it doesn't yet. And I'm going to leave it at 0 because this is going to be, that's the first index we want anyway. So I is going to be at 0. Doesn't really matter too much where I put that. And then what I'm going to do is declare I again. And this is similar to something I covered in the previous video where I'm going to increment this value because I'm going to use the linear pattern with feature patterns. It's actually going to just repeat these features over and over again. So if I make this, if I set I equal to I plus 1, then every time it loops, the increment is going to change and I'll be able to address the next item in the list. So that's how we're going to do it. So now I'm actually going to make, let's see, offset, instead of the index being 0, it's going to be I. So now we're going to grab, the offset's going to be each item in the list. So there we go. There's my offset. And just to make this more obvious what's going on, I'm going to set this to a bigger value, 10 inches. All right, cool. So that's that. I'm also going to add a 0 inches or yeah, cool. Okay, now we just need a linear pattern. I'm going to set it to feature pattern and I'm going to hit reapply features. That's what makes it actually run over and over again instead of this way. It just kind of like grabs the things that were made by those features and patterns them instead. So in this case, we actually want the features to rerun. We don't need to do the sketch again, but we do need to run offset. We need I to recalculate itself every time. And we need the extrude to happen again because it's the thing that's being driven with the offset. I'll pick the top plane, and really we actually don't need any distance because that's being driven by the offset. So we're going to pattern it at 0. This will be our count. And now there we have a linear pattern that is adhering to our arbitrary list of values. And if I add a value, it will add an instance, 20 inches. So there you go. That's one way that you might use arrays in Onshape. I've got another pretty cool example that's very different. So here's an example of a model, and I'll dig into custom hardware libraries later in another video, but this is a relevant example for us here. This was a spring that I modeled that's configured, and it's got a lot of cool stuff going on. For one, it has the name configured and tells you what the McMaster part number is for the spring. We can choose from a number of different starting angles and wire diameters, as well as a right or left-handed version of these springs. And so the challenge here is when you're configuring something like the McMaster part number, you can only really easily drive that from one configuration input at once. But in my case, the 120 degree, this exact spec on the left-hand version needs a different part number, and in fact does have one. So the way that we can do that is using an array. Down here in my feature list, I have this part number variable. And if I drag this way out, you can see what we've got. Maybe that makes sense. It's a little bit convoluted, but let me show you how I'm reading it. First, I'm noticing that there are 2 brackets opening this. So that's letting me know that I probably have I have nested arrays, meaning I have an array of arrays, a list of lists. So I've actually got the right-handed part numbers here, and I've got the a comma separating that list from the other list. And then I've got the left-handed part numbers there. And then I've got some other variables higher up. So when I choose right-handed, it configures my index. When I choose right, it's an index of 0. When I choose left, it's an index of 1. And then the list index is what's driven by the size and angle. So I have both of those things going here. So what's happening is the array is grabbing either the first list or the second list based on whether it's right or left-handed. And then inside of that, this next index is going to grab whatever number item from within that list. So it's a way of having kind of like, again, a row of a table of rows and columns. This is very much like a spreadsheet. Like if I had in the columns, it would say right-handed, left-handed, and then in the rows, it might be all of these items. That's how I'm thinking of this. So that's how another pretty unique way that you can use arrays in Onshape to do some powerful stuff. So I'm getting one value configured using a combination of inputs. Now, speaking of functions that are not going to autocomplete for you, that are hidden, but they are here, there's a lot that pertain to arrays beyond just the size one that we used here. So I just want to show you a few of those so you can get an idea of what's available. For one, there are actually overloaded versions of the min and max functions from the previous video. So if I come in here, I'm going to make this a normal size again. I can get the max value of whatever is in this array. So imagine you have 100 values in here and you don't want to keep track of which one's the biggest. You can just say max. And instead of that XY, we're not getting the autocomplete, but there is another overloaded function where I can put my list, and it takes an array as an argument and it returns whatever the biggest item in the array is. Same with the min function. There's also an average function, and I can put in a huge list of numbers and get the average. I think that's pretty interesting. If I want to add something to an array, I can say that I can say list. So I'm redeclaring that variable. I'm saying list is going to be equal to append list with whatever my new value is, 26, let's say 26 inches. And it's gonna fail. Oh, it's because it's set to length. So I'm gonna copy that, come over to any, paste it in. Okay, great. So now you can see we added 26. Now, I don't know why I would actually do that versus just adding it here, but if you needed to, you can append things. You can grab, you can check if a number is inside of your list. So I can say is in, and I give it list, and I give it the thing I want to look for. So I'm going to say, is there 4 inches in here? I think I have the arguments backward. So I'm going to say 4 inches is 4 inches in list. Excuse me. And it's going to return a Boolean. So it's going to say, no, 4 inches is not in the list. But if I go 5 inches, it's going to return true. So see the video on Booleans to understand what to do with that. So is in is a pretty cool function. You can also create an array of Booleans. In the previous video, I had, let me see here. I had these Booleans, and I have this meets all criteria function in which I used and operators. And you can go, if this is true, and this is true, and this is true. But once you start getting a lot of them, it becomes a little bit cumbersome. So there's actually a function for that called all. And inside of that function, I can put an array of my variables. Is above min, is below max, is odd. And that produces the same result a little bit more concisely, especially the bigger this list gets. There is also an any function, which is basically the same as using or operators. So if this is true, or that's true, or that's true, or anything in the list. So the any and all functions can be used with arrays. Let's see, similar to what I was saying about the is in function, there's also an index of function that will tell us, let's see here. I think the arguments might be reversed from the is in function on this one. Yeah, there it is. So if you have a number and it is in that list, you can get it to tell you what the index of that number is. So in that case, 5 inches is there. And if I give it 4, it gives a -1 because that number is not even in the list. So it's another way that you can check if something is in the list. And if it is, you get the index for that. So if you wanted to address that downstream, you can. Another interesting way to generate an array is using the range function. So inside a variable, I'm going to say this is my number list. And I can use a function called range. And this will take us from a number to a number. So if I put, 3 to 17, then it's going to give us every number from 3 to 17 as an array. And I can even put in there, again, this one's overloaded. So if I add a third argument, I can put what size the steps are. So I can say 0.5. Oh, excuse me. No, I can say how many steps I want. 50 steps. So there we go. So now I've got 50 items in here going from 3 to 17. And then in a future video, I'm going to cover even more ways that you can manipulate these lists of numbers once you have them. Right now, a range all by itself, there's the use is somewhat limited, but you can begin to apply functions and other math to these lists of numbers in a batch, and you can start to put out some pretty interesting results. So see me in the next video where we're really going to just break this thing. See you there.